And I do promise you, tomorrow you will have fun with vectors. After today, you will know what a vector is. You'll understand vector direction conventions, and you'll be able to draw a scaled drawing of a vector. And I've already given you a little bit of a tease here, a bit of a hint as to what a vector is. If I asked you right now, what would you say a vector is? Come on, please break yourself.
Array?
Array? Yeah, that's a mathematical array, I suppose. Most people wouldn't call it array, but it is for math, yeah. Well, guess what? It's simply an arrow that represents a vector quantity. You can write stuff down right now if you want. If you want to sit back and just take in the gloriousness that is vectors, you can do that. Jimmy crack corn, I don't care. At the end of today, you need to know what a vector is, so you do what you need to do. So what is a vector? A vector is simply an arrow that represents a vector quantity. It's a little bit of a misnomer kind of thing. When we say vector, we mean the arrow that is the scientific model of a vector quantity. So just like the models that we calculated yesterday. The length of the arrow represents the magnitude or size of the vector. Now, people quite often, later in the course, and even in grade 12, they say to me, I don't know what magnitude means. The magnitude just means the size, how big it is. That's what magnitude means. And that the direction that the arrow points represents the direction of the vector quantity. No big surprise there. I had a student once that when they were measuring vectors, they wanted to measure from there all the way. They liked measuring just to there because it was a nice, hard, straight surface. And they were always off by a little bit, and they couldn't figure out why. And I finally figured out why. It's because you got to measure, not to there, all the way right to the tip. That is the length of the vector. Okay? Anybody ever watched Despicable Me? So the first time I saw that, I was in the theater here in Dauphin. Might have even been one or two of you there. And I was the only person in the room laughing, oddly enough. Committing crimes of both size and magnitude. Why don't you guys lighten up a little bit? Jeez, tough crowd. Tough crowd. Okay, so what is a vector quantity? That's the only bit of fun you're going to have today, so. What is a vector quantity? It's a quantity that has a direction associated with it. The big four are displacement, velocity, acceleration, and force. And you all probably have some kind of general understanding of what those are. Displacement is what?
Volume?
Not that displacement. So, do you say correct? How far something moves, not only how far, but in which direction. How far and what direction. Velocity is speed with a direction. Acceleration is how fast the velocity changes with a direction. Are you seeing the trend here? And force, if I push, I have to push in a certain direction. Okay, those are the big four. There are others. They're a little less common, not quite as known. But those, again, are the big four vectors. The opposite of vector is called a scalar. I was convinced that Despicable Me 2, there would be a supervillain, he would have a sidekick, and his name would have been Scalar, and I was very disappointed when that didn't happen. I thought that would have been funny. Again, I would have been the only one laughing in the entire theater. Scalars are quantities that do not have a direction associated with it. Things like mass. When you measured the mass, or when you looked at the mass of those lab weights the other day, it's 500 grams. No one says 500 grams west, or 500 grams to the right. Time. No one says 47 seconds left. Doesn't make sense. Cost. $14.97 south. Doesn't make sense. So vectors have direction, scalars do not. Examples, maybe identify them. Oh yeah, clickers. The question is, which of the following properties in physics do you think is a vector? Is it speed, density, momentum, or volume? None of those are the big four that I just gave you. So you have to come up with one.
Is there a protocol in the lab, or just use it as necessary?
Yeah, they're always, we've never been able to come up with a good one. So, yeah.
Can you put two
It'd be a good idea to warn people that you're using it. Maybe.
Can you put two
We're using it.
Okay, go ahead. It never bothers me because I have those. Can you put two answers? You can, but I won't say that there's two answers here. I know that the clickers allow you to enter two. And normally I could tell that who hasn't answered, but all I know is that there's 11 of you that haven't answered. I'm waiting for, it was 3 and then it went to 4. One person. You have to press enter. Oh, how does that happen? I'm going to change their answer. Come on, anonymous people out there. Press enter. I'm going to hit stop. Correct answer is C, momentum. Momentum. Let me just go back here. Oh, you said speed, Mr. Bennett. No, I said velocity is speed with a direction. Right? Velocity is speed with a direction. Speed itself is a scalar. Sorry. Density, do you say like 47 grams per cubic centimeter west?
Yes.
No. Momentum has a direction to it. Momentum is a vector. Volume is not. Sorry. Oh, now I'm flipping it around on you here. Which one do you think is a scalar? Which one does not have a direction? Is it gravitational field strength, density, magnetic field strength, or torque? And if you were paying close attention just seconds ago, you would know the answer. Is it gravitational field strength, density, magnetic field strength, or torque? Waiting on one people. One person. Press enter.
Click enter.
You've had a minute. Too late. Yes, well done. B, density. Gravitational field strength has a direction, it's down. Magnetic field strength has a direction, you probably don't know that, but it's from north to south. Torque has a direction as well, it's either clockwise or counterclockwise. Okay, you can put the clicker down for a moment. By the way, from what I understand, a lot of the universities are going towards these kind of things, like in the big lecture halls. So you might be in a room with like 200 or 300 people, and everyone's got one of these, and the professor does stuff just like that, and it just sort of keeps you on task a little bit and paying attention. So I think you have to buy them in there. So. I haven't seen them in use though, at the university myself. Vectors are represented algebraically by a variable with an arrow over it, such as a velocity. Again, you don't need to write every word down. Summarize it. Okay? If you see something like this in a book, a little V with an arrow over it, that's a vector. When you're handwriting them, it's just V with sort of a half arrow. Could be A with a half arrow for acceleration. Okay? In the old days before like desktop publishing kind of thing, they just put things in italics and bold to make it look like a vector. Okay. Pause, just put your pen down for a second, just listen, okay, and I'll give you a chance to copy. When representing a vector graphically, in other words, when you're drawing a vector, you can move the vector any way you like. You can put it anywhere on your page. You can draw it here and then copy it and put it here. It can go anywhere on the page as long as two things remain the same. The length of it must remain the same, and the direction which it points must remain the same. Okay? For example, the two vectors shown below are considered equal, even though they do not have the same starting points. And most kids never have a problem with this. Every once in a while I see someone that says, but it's not the same, it doesn't start in the same place. X and Y are the same. Why? Because they have the same length and they point in exactly the same direction. They are equivalent. It is the same as doing something like this. That two in blue and that two in red mean the same thing. They mean two things. right? They're different spots, they're different colors, they're different font. They mean the same. These two vectors are the same. You can move vectors around. People might say, Mr. Bennett, I don't know what units to put after my vector. You have to remember that vectors, we're not talking about, vectors are not a quantity. Vectors are not like velocity. Vectors are not like force. It's a type of quantity. Okay? It's just a characteristic or more like a type, I guess, would be better. So the unit of the magnitude of a vector depends on the type of vector you're representing. For example, the displacement vector would be measured in meters. Velocity vector would be measured in meters per second. Force vectors would be measured in newtons, and so on. Okay? Don't worry about the units. Vectors don't have special units or anything like that. Now, let's talk about the direction vector. Directions, there's about 3 conventions, and unfortunately you're going to have to know them all. There's 2 that are complicated, 1 that's pretty simple. Don't worry about that unit stuff. Don't even write that down. It's not working. It's more of a reminder for me to say it. Okay, here's your first vector question. A man is following a scavenger hunt. It is the worst scavenger hunt in the history of scavenger hunts. He is to walk plus 35 meters and then minus 10 meters, and then he gets his prize. Whoop-de-doo. What is going on here? What does plus 35 meters mean?
35 minutes from where he is right now.
From wherever he is, which we will probably label 0, he will walk
35 meters.
35 meters to the right, and then he will walk
10 minutes or less.
10 meters left. Where is he? At position what? He's at position plus 25. Okay, so there's 2 vectors there. There's plus 35 and minus 10. Plus just means right, negative means left. No big surprise there, right? You all know that from, I don't know, when do you start that in math? Grade 8 maybe? I don't even know anymore. Grade 9? Maybe even earlier. Number lines? I don't know. Okay, plus means right, minus means left. What if we're talking up, down? Plus is up, minus is down, just like math. No problems. Everyone gets that, right? No worries. Here's where it starts to get a whole lot harder real fast. An airplane is traveling at 200 kilometers per hour at 40 degrees south of east. Remember, just going to fix this here. An airplane is traveling at 200 kilometers at 40 degrees south of east. What does that mean, south of east?
Start traveling.
I think everyone knows their directions. Certainly, I hope you know left from right. North, east, south, and west, right? Never eat soggy wieners, right? When you watch the 6 o'clock news, do you know why they call it the 6 o'clock news? Because it's information from all directions? Do you think I'm lying, or what do you think? I'll leave that for you to decide. 40 degrees south of east. Here's east. Which way is 40 degrees? Oh, sorry, which way is south? Down. How far? 40 degrees. So if I were to draw the vector in there, where would I place the 40? Would I place it above, or would I place it below? Above or below? And I hear lots of above. Is that right? Is that 40 degrees south of east? Yes. 40 degrees south of east. Okay, so the last direction is where you start. You kind of got to work backwards. You start east. You look south. How far? 40 degrees. Most students hate that convention because you have to sort of work backwards. They hate it. Okay? Another convention is east, 40 south. You start east. You go 40 degrees to the south. Most people prefer this one, but you kind of got to know both. Is there another way to represent east, 40 south? Anyone? What's the other way? south 50 east. So east 40 south and south 50 east are equivalent, equal to each other. The rule is that the east and the west, the directions just switch, and what do these numbers have to add up to? 90 degrees. Okay? So if you're writing a test and I ask you to give me a vector, I need to have on my answer key, I need to have this one and this one because I don't know which way you're going to pick, right? Both are equally right. There's no penalty. They're both exactly the same. Okay? I'm not getting a lot of feedback from you guys today. Everyone must have had sleeping pills at lunch. No? Get out your clicker. Okay, the answer is A. Okay, this is the third convention. These two, I count these two as the same convention, just sort of a different way of doing it. Here's the third one. This is the one that pilots actually use, navigation people on boats actually use. If you're in a plane and you're landing on a runway, the name of the runway, the number of the runway is actually the direction that the runway points. When you put 0 at north, 90 at east, 180 at south, and 270 at west. So if you're landing on runway 27, you're going to be landing facing west. That's how it works. So it starts at north and it goes clockwise, like so. And if you didn't draw this little figure in, you really need to, because that's pretty important. Anybody in here done the unit circle yet in math? Anyone? No? No unit circle people? Excellent. You won't be confused. When you get to math, the math people start like this. They put 0 here and they go this way, just to make it confusing. This is the way the real world operates. Okay? So a sailboat moving at a bearing, we call this the bearing method as well, a bearing of 210. I got into the habit of putting bearings in square brackets just out of convention. It's kind of a little thing that I do. So if you see square brackets like this, that means bearing method. So we're heading in a direction of 210. Which direction is 210?
Somewhere on southwest.
Well, past 90, past 180. How far past 180 is it? 30 degrees. Okay, 30 degrees. Make sense? Okay. What would be another way to say 210? What is 210 equivalent to? Would be equivalent to south 30 west or west 60 south, or I guess you could say 30 degrees west of south or 60 degrees south of west. Yay, 5 different ways to say the same direction. Fun. Well, did you want me to leave that up there? I'll pause for a second. Which vector is at a direction of 300 degrees? Which of these vectors is 300 degrees? And you have to look a little close and do a little bit of thinking there. You can probably eliminate a couple. You're going to have to be careful on the other ones. Correct answer is D over here, 300 degrees. Why? This here is 270, right? So 300 has to be past that, right?
I was thinking it in angles there.
What's that little angle in there? How much is that in blue? 30 degrees. We would write that as west 30 north, right? West 30 north. Okay, I think you guys are getting the hang of this. Okay, now to the rulers. Scale drawings are often used to represent vectors graphically. For example, a vector of 300 newtons could be drawn or shown as. Now, when you draw, I'll let you guys write that down. No feedback at all. I'm doing it. I'm going to check the first one here for you. 25 kilometers at 30 degrees west of north. What's the first thing you need to decide on? your scale. You could do direction first, but most people start with the scale. I recommend the scale simply so you don't forget. Because quite often I have to give people 2 out of 3 because they don't give me the scale. So start with the scale. 1 centimeter equals 5 would most people come with. Could you say 10? Absolutely. It would just be 2.5 centimeters long, right? Could you say 1 centimeter equals 25? Sure, it would just be only 1 centimeter long. No problem, okay? But generally you want to make it sort of a reasonable size. So 1 centimeter equals 5 kilometers. I'm going 30 degrees west of north. I call the north line, I call it the reference line. So you need a small little line that you are defining as north. That is straight up and down, north. And from there I got to go 30 degrees to the west, right? Oh, where'd my ruler go? Left it on the last page. That's not 30 degrees. That is 90, so I gotta go.
150.
Everything's a little bit different here. I gotta go and put it at 120. Like so, right? And I'm going 25, so I gotta go 5 long there. How's that? Something like that? Is that what you had? Yeah? Thumbs up, everyone? Good? Yeah? So again, when I'm marking these, I have a quick look at it. If it looks roughly 30 degrees and roughly 5 centimeters, I'm not getting my ruler out. If there's, I can usually tell if it's out a little bit, and then I get the ruler out, and again, plus or minus 3. What about the angle? You think there's some wiggle room there? Should I give you a little bit of wiggle room? How much do you think, Kyla? Same generous offer. 3 degrees. More than enough. I've never seen anybody be exactly 3. It's usually 2 if they're off. 1 or 2 degrees. Very few people are outside that. Okay.
I forgot, how did you read that again?
30 degrees west of north.
No, the second one.
Oh, north, 12 east. So you look north, go 12 degrees, east. Go. Okay, 15 meters per second at north, 12 east. North, 12 east. Means look north. So you draw a little reference line. That's north. It doesn't have to be that long, just enough to define north. 12 degrees to the east is going to be to the right. Oh, and I did the cardinal sin. I didn't do what?
Scale.
I didn't do my scale first. So 1 centimeter equals, some of you probably said 3, some of you probably said 5, makes no difference to me. I'm saying 3, so I got to go 5 at north, 12 east. North, 12 east. So I'm going to go like that. Oh yeah, good one. And I'm going to go 12. No, I'm going to go 5. All right, so it's very close there. I'll go with a dash line. You know, like a 10 goes there, something like that, right? Everybody have something like that? Pretty close, right? 45 newtons at 64 degrees above the horizontal. Just in the interest of time, I'm going to just draw these quickly freehand. I'm not going to measure them. So 45 newtons at 64 degrees above horizontal, it would be something like 1 centimeter equals, I would likely go 15 newtons. You could go 10 if you want, and then be 4.5. Either's fine. 64 above horizontal. Horizontal just means flat. Oh, that's terrible, flat. Let me do this. There's flat. Jason asked, and there's probably a few others that were wondering, do I go this way or do I go that way? And it doesn't say, so either is fine. This would have to be 64 degrees. How long would it have to be? If 1 centimeter equals 15, then it would have to be 3 centimeters long, right? Good? 8 meters at 175. 180 is straight down, so draw your reference line. You should always have a little reference line. If I'm going to be measuring, I have to measure from something. You should always have a little reference line. 175 is going to be down like that. 8 meters, I would have something like 1 centimeter equals maybe like 2 meters or something like that, right? And this would be a 5-degree angle in there. Does everyone sort of get the direction stuff for the most part?
Yep.
Pretty good. There might be a few little boo-boos that come up, but I think everyone's probably at about 80 to 90% good. Tomorrow I'm not here, so I need to quickly tell you what we're going to do tomorrow. Okay? I need to give you one little tidbit here. Okay? Tomorrow you're going to be doing the great Talk Like a Pirate treasure hunt. Okay? I've got a video from a year ago that explains it, because oddly enough, a year ago I was away, and Mr. Strozek was in the sub for me. I found the video. It explains everything. Mr. Strozek's in tomorrow again, so it's kind of weird. You're going to take your loose leaf, you're going to make it into a big piece of paper by taping it all together. And I explain this in the video. So you're going to take 2 pieces like this, 2 pieces like this to make a big piece. You're going to need a partner. You're going to need your ruler. You're going to need your protractor. Okay? When you add vectors, can you just give me like 2 minutes, you guys? I know you want to pack up. You need to know this part. When you add vectors, this is the way you do it. I'm giving you the very quick version. There's vector A. Let's do this in a different color. There's vector B. How do you think you add vectors together? Like if this is 6, and the red one is 8, when you add them together, what do you get?
14.
And it's not 14. It's none of those. Here's how you add vectors. You place them, what we say, tip to tail. So this is the tip of the black one, and you put them like that. Okay? Just like the guy on the scavenger hunt that went 10, like that, right? Tip to tail. So tomorrow you're going to do a little treasure hunt thingy with pirate things, and it's a lot of fun, and someone will pretend they're a pirate. It'll be great, right? You're going to be drawing a whole bunch of vectors. You're going to be drawing them tip to tail. Okay? You should have like something like this when you're done. Does that make sense? Because you're going to have a little treasure map, and you have to follow the directions. Okay? Tip to tail. Goodbye.